Welcome everyone to Datadog On. Datadog On is a series of episodes where we invite engineers working every day on building Datadog itself to talk about a piece of technology they're using, a process they're following, basically to share and to get transparency on how Datadog is built. Today, we are going to be talking about building reliable distributed applications using Temporal. This episode and any other of the Datadog On episodes are recorded, so this one is being recorded as we speak. If you want to watch afterwards, you can always go to datadoghq.com and share the recording with colleagues and other people who might find this interesting. So a little bit of housekeeping. So one of the things that we love about Datadog On episodes is to make them as interactive as possible for with questions coming from the audience. So if you want to make any questions, you don't have to wait until the very end. We are going to leave 15 minutes at the very end for questions. But if you have any questions throughout, there is a Q&A button in your Zoom client. So find that button in your Zoom client, leave the question there, and at the end, we will try to go through as many as possible. Don't use the chat for that, for the questions, so I'm able to tell apart the chatter from the actual questions that you want to pose to the speakers. By all means, feel free to use the chat to say hello, where you're from, or to discuss with the rest of the attendees during the event. Okay, so my name is Ara Pulido. I'm one of the co-organizers and co-hosts of Datadog On. So if you have any questions about this or any other episode, or you want to propose a topic or anything else, please do reach out. I'm happy to answer any questions. But the important people today to talk about Temporal and how we use it at Datadog are Alan and Loïc. Alan, do you want to introduce yourself?
Yep. Hi, my name is Alan George. I'm the engineering manager of the Workflow Automation team. And the Workflow Automation team is part of a broader suite of products at Datadog that are aimed at making changes in your infrastructure.
Cool. Loïc?
Yeah, so I'm Loïc. I'm a software engineer at Datadog for the past 7 years or so. And over the last 4, I'm part of the Workflow Engine team who introduced, managed, operate, and scales the usage of Temporal internally at Datadog.
Cool. Thanks for joining. So one of the things that we usually do when we start these episodes is talk a little bit about Datadog scale. So some of the decisions that we make and how we build things are based on this scale. So just to give you an idea, Datadog has more than 29,000 customers, and we are an observability and security platform. So we basically gather telemetry and ingest telemetry from those customers, and those adds up to hundreds of trillions of events that we ingest and process per day. And to give you a little bit of an idea of our engineering organization, we have more than 2,000 employees in engineering. And today we're going to be talking about a key technology that we use at Datadog, which is Temporal. Temporal is an open source project. You can visit their site at temporal.io. And once you visit their site, at least it was for me, it was a little bit difficult to find a good definition of what it is and why would you use Temporal for. After a little bit of searching, I found this definition on their learning website that basically says Temporal is a developer-first open source platform that ensures the successful execution of services and applications. That's the definition that I found. And also, aside from this definition, I basically saw throughout their site the concept of durable execution. So with those two things in mind, that definition, that it was the best one that I found, and the concept of durable execution, maybe Loïc, you can give us a little bit of an idea what this all means from a practical point of view.
Yes, sure. So there is actually 2 parts here. First, there is execution, which is a synonym of a program or a function. And in Temporal, this is what they call a workflow. And then there is durability, And we can describe durability by what properties it brings, namely state preservation, automatic recovery, and failure isolation. And with temporal, basically, if a workflow gets interrupted, either intentionally, like during a deployment, or due to an outage, it can restart later and picks up right where it left off. And that's basically the concept behind state preservation. Temporal can also automatically retry transient errors and even mask those failures so they are not noticeable by end users. And so failure masking is a very much desirable property for basically any distributed system. So that's a bit what I mean by automatic recovery here. And finally, there is failure isolation. And this means that if one workflow fails, it doesn't impact others, so errors don't cascade and crash the entire system. And in temporal, each workflow execution is independent, and workflow, however, can still cooperate between each other by exchanging signals, for instance. So yes, basically, temporal provides a platform and a framework to let you write durable functions which have such properties, and they call those functions workflows.
Good. So it makes a little bit of sense now. I think we are going to be talking about workflows a lot, and we are going to actually talk about workflows in two different senses, the temporal workflow and actual Datadog workflows, which are similar, but not really. They just happen to have the same name. So what type of applications do you think need this durability, Loïc?
Yeah, so actually there is many useful cases when you need durability. The first one I can think about are for event-driven applications, or what I call EDAs. And when you are building EDAs, actually there is two main designs, a broker topology and a mediator topology. And in the broker setup, components talk to each other through message queues, and they react to events and produce new events in response. And so communication is asynchronous. The architecture is very dynamic. That enables high throughput and low latencies, especially when you work in distributed systems. And it's usually very scalable. And in contrast, you have the mediator topology, which has a central component, which is called the mediator, which manages events and coordinates what goes where, basically. So I like to say that temporal acts as a little mediator. It dispatches events to what temporal calls workers, and it handles recoveries and retries. So basically, with a simple queuing system like NATS or RabbitMQ, you will be able to build EDAs with a broker topology quite easily. But temporal will let you build EDAs with a mediator topology. And actually choosing between the two architectures is usually a trade-off. Either you favor higher scalability, lower latency, and you opt for a broker topology, or you want workflow control, error handling, and recoverability, and you favor a mediator topology. That being said, I think temporal is not limited to EDAs. Actually, we use it at Datadog for other things. Another thing that I can think about is distributed transactions, basically to provide a sense of atomicity when some state has to change in multiple systems or not at all, basically. And temporal helps here by letting you build sagas, which is a typical pattern for implementing distributed transactions. And so a saga is essentially a workflow with compensating actions that are clearly defined and that trigger in face of a failure and actually roll back any in-flight change. And so the nice benefit of temporal workflows is that you are guaranteed that if you manage to start them, they will run to completion. But it's not easy still to write sagas in temporal, because distributed transactions is a complex topic in itself. But without systems like temporal, your life is usually even harder. Another thing I can think about is we also use Temporal to implement batch processing. And batch processing workflows are often like very long running. They can run multiple hours, days, or sometimes week in our case. And they process a long list of things. And here, recoverability and checkpointing features of Temporal are crucial. So you don't have to restart those long-running processes from the start in face of failures. So you want to mask those failures as much as possible. And finally, another use case is when you want to implement your own domain-specific language to describe workflows. And this is what a couple of teams at Datadog, like Alan's team, is using Temporal for. And essentially, you're able to create low-code solutions on top of Temporal. And Temporal acts as the execution engine or the interpreter, and it's running workflows that users can define with this specialized language.
Cool. Yes, I really like how you mentioned that usually the type of things that you build on top of Temporal, like distributed system or SaaS, are difficult, and Temporal doesn't take all that complexity away, but at least some of that complexity away. So I think it's very important to that you mentioned that it's not like you build on top of Temporal and then all your problems goes away. It has building complex systems is difficult in itself. Okay, so the use cases are more or less clear. And how does Temporal provide those guarantees? What Temporal brings to the table for people wanting to build those systems?
Yeah, sure. So the first thing is workflow functions in Temporal have a hard constraint that you have to comply with. They have to be deterministic. And by that, I mean that if you run them multiple times, they will produce the same outcome, meaning the same outputs and side effects. And they can't execute any non-deterministic code, like making any API call, write to disk, or generating random numbers, and many other things. And these determinism constraints, coupled with the Temporal SDK, is what enables durability, because it's making it possible to pause and resume workflows at any point while still looking like you are writing imperative code. So with that constraint, you know that on failure, workflow functions can always be run again from the start on a new node, providing you know the function input, because you are sure that workflow code execution is side effect free. The problem is side effects are very desirable by virtually any system, so it can actually do interesting things like interacting with a human, for instance. And so to work around that issue, Temporal forces users to wrap non-deterministic code in what they call activity functions. And in those functions, you are free to do anything. So activities can be called, obviously, from the deterministic workflow functions using the Temporal Go SDK. And so Temporal will record each activity's input and output. So if a workflow function calling an activity needs to be rerun because of failure, it can swap the activity execution results by what it's recorded instead of rerunning the activity and retriggering side effects. So basically, the first time a workflow function runs, side effects are triggered and recorded, and the second time they are just skipped. So each workflow execution will keep track of all its activities, inputs and outputs, among other things, in what Temporal calls a workflow history. And this is basically a paper trail of the workflow execution. And that paper trail is used to recover and rerun workflow from their point of interruption when that occurs. So even if the history is partial, if you are like in the middle of a workflow execution, you can still rerun the function up until the last event you have in the history and continue executing from there. So that's how state preservation works. And those workflow histories, they are stored in the Temporal server backend, which is actually a pluggable database. And all the available backends, so we have like Postgres, MySQL, Cassandra, and the one Datadog contributed upstream, namely SQLite, are actually like durable data stores, but they provide different availability guarantees and scalability. So picking one to suit your needs is actually rather critical.
Sounds good. Makes sense. So thanks for explaining high level how Temporal works. I think this is going to, for people who are not familiar with Temporal, are going to say the aha moment. Now I understand what it does. But you're actually part of a team called Atlas. So what is exactly your team does and how it's related to Temporal?
Yes, so at Datadog, we run Temporal as an internal platform that we rebrand as Atlas. So basically, we offer durable workflows with defined SLAs across all our data centers and cloud providers to the rest of the engineering org. It's an internal platform. So Atlas integrate with our Kubernetes, our CI, and other platforms that are built inside the company. And so engineers don't need to worry about managing low-level details. They just focus on building features that requires durability. But actually, Atlas is a more than just like hosting temporal servers. For instance, to make things easier, we also developed the Atlas SDK. And this SDK wraps the Temporal Go SDK by adding like type safety, reducing boilerplates, improving discoverability, and increasing encoding safety, for instance. So our engineers now define their workflows with clear input and output schema in Protobuf, and we auto-generate code to reduce common errors. And this has proven to be useful quickly to avoid incidents, especially when you are refactoring complex workflows, because things fail at build times instead of runtime. So we also integrate our platform with the other internal ones at Datadog, like our deployment platform. And we provide, as a team, Helm chart, so our customers don't have to write and actually manage them. We also build tooling to help dealing with temporal drawbacks, like having to deal with workflow versioning, which is one of the main pain points you have to cope with when you work with long-running durable code. And the TLDR on that is that backwards compatibility is mandatory to provide durability guarantees. And we are actually starting an open source project to write a Kubernetes controller to simplify that for most workflows that you should check out on our Datadog GitHub also. Another thing is we are also looking forward to implement resource-based auto-scaling thanks to recent changes in temporal server and SDKs. And as we operate as a platform, we will be able to enable that on every single worker our engineers have built so far, which can quickly make the company save a ton of money, especially because one of our main use cases is rather seasonal. And so essentially, we are continuously trying to improve the platform to the benefit of the entire engineering org. And our goal is to operate and manage anything that is non-business specific. So engineering time is focused on delivering business value.
Yeah, I think that's one of the main benefits that people when talk about internal platforms is that whatever improvement you make, it's expanded to basically every engineer in the organization, which is great. Mm-hmm. Okay, so one of the things that you've been building on top of Temporal, those extensions, we have here on the slide the large payload service that I know it was almost built for Alan's team use case, which is large payload service, which is by the way open source as well. We put a link there to the repo. So what it does, that extension, and why it's so important for our use case.
Yeah, indeed. So one limitation of Temporal is that it uses gRPC behind the scenes. And it means that large request payload can be a challenge because they hurt gRPC servers, basically. So for some teams like Alan's teams, workflow inputs can grow beyond gRPC typical limits of a couple of megabytes. So basically, we built a data converter and a content addressable storage solution on top of cloud providers' blob storage to work around that issue. And the content addressable stores basically holds the actual large payloads, and workflow histories only hold reference to those. So each worker, which is basically the binary which executes workflow functions, is responsible for downloading the actual payload when needed, like when you are starting a workflow or an activity, and to provide that payload as input to the workflow function. And this is done transparently and without going through the temporal gRPC server. So our customers don't have to think about large payloads anymore. That being said, I wouldn't recommend using this solution as a pure data processing platform because it has a lot of overhead, and it's that as data is easily duplicated and constantly sent over the network back and forth. So there are better solutions for that use case. I can think of, for instance, to Spark. So you should probably use the large payload service only to handle edge cases when you don't want to provision a full Spark cluster for a tiny amount of operations. So yeah, as you were saying, the large payload service is open source, so you can check out on Datadog GitHub.
Sure, feel free to check it out, and obviously take into account the recommendations that Loïc mentioned before jumping into using it. Okay, so let's talk a little bit about scale.
Mm-hmm. Yeah, so we now run tens of temporal server instances. We have like hundreds of workers that are running and constantly polling for tasks, and more than 500 engineers that having built something with the platform at a point in their life. And we run hundreds of millions of workflows every week.
Cool. By the way, this is I think it's interesting, and I think once now we are going to be talking about Datadog Workflow Automation and a product that we actually built on top of Temporal. But it wasn't the first use case. So the first use case was software delivery lifecycle. And actually, we have another Datadog episode from a couple of years ago, if you want to check it out as well, talking about software delivery at Datadog. And that's where we talk about the first time that we talk about Temporal in a Datadog episode for that particular use case. But actually, now we have grown past beyond that use case, isn't it?
Yes, indeed. Temporal basically started as an internal solution for infrastructure automation, but its success led to a broader adoption across Datadog. And it's now an integral part of how we basically speed up the development and bring new products or new features basically to markets. Great,
thanks. Which brings us to one of the products that we are going to be talking about, which is Datadog Workflow Automation. So Alan is going to be talking about how his team has built Datadog Workflow Automation. But for those of you who've never used Datadog Workflow Automation, Alan, can you give us a little bit high-level product overview, maybe?
Yeah. So for all of you who have used Datadog, or maybe if you haven't, Datadog has done an amazing job of providing a huge amount of telemetry to you, right? And so whether that comes from your infrastructure, whether that comes from your applications, whether it comes out of the box or is stuff that you build yourself. And on top of that telemetry, we give you the opportunity to define signals. So whether that's monitors that you build, or again, stuff that comes out of the box, like security rules or even other kinds of monitors. There's something that was missing there, and that was the ability to actually act on all of these signals, right? And that's where workflow automation comes in. And workflow automation along with its sibling product, App Builder, is part of a suite of products that Datadog is building right now that allow you to respond to those signals and make changes in your infrastructure based on that. So as you see on the screen over here, workflow automation is kind of this low-code experience where you can define an execution flow, basically a little program, right, that can respond to a signal and can start like going through control structures and making changes in your infrastructure. And they have a number of features, right? So if we were to think about workflows, you have like DAGs, you have triggers. We allow you to integrate with over like 600 different API endpoints. We have all of the control structures that you are interested in, like loops, branches, so on and so forth. And of course, on top of that, we offer you huge amounts of security, right? Like you want to be able to control who is able to run these workflows and like do all sorts of like granular access control and so on. Of course, we built all of this on top of Temporal, right? So this is a little programming language that we built, right? And we took this programming language and we were like, okay, we need to run this thing somewhere. So we built out an interpreter and then we were like, great, we need a platform to run it on. What is this platform? And that platform is Temporal, which is why I'm here. So, like as a product team, one of the advantages is that we can build on a lot of the work that Loïc and the team that he's working on is doing. And so we can really concentrate on the 3 problem domains that we care about, which is like designing the actual workflow automation DSL, right? Designing a little interpreter to run it, which is kind of like similar to what you would do for like a Python interpreter. But the difference being that you have to be able to have this thing be fault tolerant and be able to replay. And finally, because we are thinking of running things at scale, we actually do run things at scale. We have to deal with all of the standard distributed systems problems that many people who are interested in working with Temporal have to deal with, right? So these are the product problems that we deal with, and these are abstracted. A lot of the other stuff is abstracted away for us by Temporal.
So going back to Temporal, so when you started working on this product, why you chose Temporal? Obviously, it was a technology that was already used on Datadog, but it was also a decision of using Temporal. Why Temporal?
Yeah, absolutely. So I think there are 3 major reasons, right? And so the first one is that when we think about kind of like the problem space that we're dealing with, what we have is we need to be running millions of workflows. They're bursty. We need to have pools of workers that scale up and down. And it kind of lends itself to like this queue and worker-based model. And that's something that Temporal kind of like gives you out of the box, right? Like that's pretty amazing. You have this this mediator that's already there and can handle that. The second thing is that we have workflows that our customers intend to put in very important situations. So it is in the part of the remediation flow, is in the part of like the monitor flow. And so these workflows just always have to run, right? And so Temporal, again, has this concept of durable execution. As Loïc pointed out, if a workflow starts, it is going to run to completion. So that's a second thing that we really cared about. And then thirdly, like from a product point of view, we want our engineers to be comfortable writing code in a language that is familiar to them, right? And Temporal workflows can be written in Go. There are a few like calls of the Temporal SDK, but in general, it is a very familiar, great like experience. So for all of these reasons, Temporal was the best choice for us to build Datadog Workflows on.
Makes sense. So let's talk about versioning. And Loïc mentioned that versioning is particularly critical when building on top of Temporal. Having the concept of version of your application is always something that you need to do, but why is especially critical when you're building on top of Temporal?
Yeah, so I think what's important for most people to remember is that, like, because temporal is this concept of like durable executions, and you as an engineer have the concept of like, I am going to change my application over time, right? You have to kind of deal with the fact that you want your application to change while at the same time being able to replay, rerun executions. And so when we were building out what's it called, Datadog Workflow Automation, we were onboarding engineers into our team, and versioning routinely came up as one of the sharp edges. And I think there were like 4 reasons that we finally like kind of like worked out. One of which is like people don't necessarily have like the most clear mental model to start. The next thing is that, like we aren't used to the concept of like replaying executions. Third one isn't really like specific to temporal, which is like we actually have like a very incomplete like mental model of like deployments sometimes. Then finally, Loïc mentioned that determinism is a core requirement for temporal, and non-determinism is everywhere, right? So when it comes to the mental model, like I think the first thing that I would recommend everybody think about is, like thinking back to a very old concept from distributed systems of replicated state machines. One of the ways that you can build a fault-tolerant system is by thinking of your system as a state machine and making sure that this state machine's operation is always only a function of its inputs. So if you submit a set of messages, M1, M2, M3, they always generate the same set of transitions through the state machine. So that means there has to be like no non-determinism. And temporal has some really awesome ways of like marking non-determinism through activities and so on, so that it can have this property. Well, once you have this, you have to remember that executions can replay. And this, I think, has been like a sticking point for a lot of people. Like people just kind of like forget about it. And what we're used to is a world where we have this state machine, your execution just kind of runs, and let's say there's a failure. Well, kind of the execution just drops on the floor, right? And for most of us, most systems, this is totally fine. You rely on the user pressing a button again, or an upstream system kind of like retrying. And in case of temporal, because the executions are durable, what we are kind of expecting is there is a replay, the same set of messages are going to come through, and you're going to get exactly the same set of transitions. But what generally happens is that you'll make a code change, you'll forget the fact that there were these like executions that were like, halfway in the middle of executing. And what you may have done is accidentally cause a completely different set of transitions through your state machine. And what I found out is that generally everybody makes this mistake at least once, right? Maybe you catch it in a PR review, maybe you catch it in testing, but this is just something to kind of like watch out for. The other thing to just keep in mind is that deployments aren't atomic. That's actually very straightforward. Like you just have to live in a world where you can have like any combination of old and new workflows, right? So any one of these are like valid. What you just got to remember is that old workflows have to be able to process new messages, new workflows have to be able to process old messages, and there've got to be no changes in state transitions. Non-determinism is everywhere, right? Like the next slide, like just goes through a few sources of this. I think the most funny one is that, if you put in validation, you may be, oh, I'm going to make this validation a little bit stricter. And boom, an existing workflow that was valid may not be valid anymore. So just be careful, dealing with shared code, dealing with like validation, just make sure that you aren't changing existing workflows.
Cool. Thanks for those warnings for people jumping into the wagon of temporal. Another thing that also Loïc mentioned was history, workflow history, and how important those are to be able to exactly do that, replay in cases is necessary. But your team got a small problem with event history. Can you explain it a little bit so people know?
Yeah, and I just want to start off with a takeaway, like one big takeaway, right? And that is use continue as new, like design your workflows with continue as new right off the bat. Like, unless you are like, okay, my workflows are going to be super short, I'm never going to extend them in the future, right? Just think about it and say like, hey, if it's going to be long, there's going to be a chance that I'm going to extend it. Like, try to like design it for continuous new from the beginning. And here's why. Like, let's take a look at a standard like Datadog workflow. Super simple, right? It's got one step, it's got a loop. The loop has a single step inside. Well, ideally, remember, we are like running this thing as an interpreter, right? Inside a little interpreter. Ideally, all the interpreter state is sitting in one workflow. But actually, if you look at our system, we have 3 different workflows that are all coordinating here. And part of this is just like an accident of history. What happened was that we started off with the main workflow, and we were like, okay, this thing has to be debuggable. It needs to interact with an external system. Oh, we have to pull this external system. It needs to live for a long time. And suddenly we couldn't do it all in the main workflow anymore because we are exhausting or bumping up against the limits for a single workflow's event history. And so, I'm sure everybody has dealt with this. We're like, oh, should we refactor or should we just move forward? And we're like, we're just going to move forward. So we split it out into a second workflow that was just responsible for dealing with a single step in a Datadog workflow. And then when we built out loops, we're like, we're going to build on the existing abstractions that we had. And that's how we ended up with a third workflow to deal with loops. So now we have this system where we have 3 workflows. They are coordinating. Everything works. We are comfortable with dealing with the system, but I think it would have been simpler if we kind of like designed everything would continue it as new from the start. So that's my like piece of advice here, right?
And,
Not a
and
problem.
what is the limit of the event history?
50,000 from what I remember right off the bat.
Good. Okay, let's talk about observability as well, because it's quite important when working with Temporal.
Yeah, and it's pretty funny because like Datadog is this observability platform. And one thing I think that makes Datadog extremely good as a observability tool for engineers is that we end up using a lot of the tools that you are, and we are building those observability tools based on our experience, right? So one thing that I will say is that like you have seen now that we have like workflows that are coordinating and we are calling out to external systems. One thing that I really wish that we could do better and do a better job of is being able to set a single baggage item, for example, a Datadog workflow ID, at the start of all of our workflows in Temporal, and have this baggage item be automatically propagated across child workflow executions, across signals, across like activity calls, so that we can like trace this like flow through our system. I believe that this is something that we can like either improve ourselves or like go back to the open source community and figure out like a good like path forward on. In our case, we do a lot of this manually, and so it's error prone, but we would love to have more of like a platform approach to this. The other thing that I will point out here, which is kind of like a big like gotcha, is that non-determinism happens. Sometimes it happens at runtime. And finding out the source of non-determinism can range from like trivial, like, yep, that stack trace is exactly where it caused the problem, to like, I have no idea what's going on. And my recommendation to all of you is to really like invest in a solid test framework, and also like consider doing like stage rollouts so that you can, like catch any instances of non-determinism as early as possible. I found out that it can be a little tough at times.
Good. Thank you. I think that finishing with that question is very good before we go to Q&A. So we are going to go to Q&A very soon. So please do ask your questions on the Q&A button. But before we do that, there was a couple of, I think it's important that we have an open discussion. And I have this couple of questions for both Loïc and Alain, which I think is a question that most people will have after watching this, which is, what type of projects are a good fit for Temporal? So if you're building a new system, what type of systems would you look Temporal for? So Loïc, what's your one thing that if I build this thing, I would definitely go for Temporal?
And there is one thing where I like to use Temporal is when you need to model the life cycle of some entity. So it can be like a customer order on an e-commerce website. It can be for us, for instance, it's like the artifact that our build system is publishing. So anything that has a long enough life cycle, and you want to model as a single entity where you can like represent that as a single function that executes for a long period of time. The data model here with Temporal is very nice and easy to reason about. So it's a bit like thinking about like an actor framework, like Akka in Java, so that kind of things. And that's where Temporal makes things easier to do, especially in Go, where such framework don't really exist. Another thing is orchestrating microservices. So if you are a startup who onboarded to the bandwagon of microservices and you have challenges to orchestrate all of them, then Temporal definitely helps in that area.
Good. Orchestrating microservices, that one I didn't think of. Alan, what about you? What are the things that you see is a clear fit for Temporal?
I think I'm going to give, I think, a little bit more general answer. And I think I'm going to lean back on what I thought about, like why we chose like Temporal, right? I think the key here, I think, is if you have any sort of like business process or like product requirement that requires you to have an execution that must run to completion, right? Like, and so for us that was critical, like we need workflows to run to completion. I think that's actually like a great fit for Temporal, because so many of the Temporal components, so many of the design decisions are built with that in mind, right? So if you wanted to do, I don't know, some sort of like staged database migration, like you just have to get that thing done, and that you have an automated series of steps, maybe something like that, yeah, like I think that's like really the key thing. I would ask, like, look at your problem domain. Do you really need this thing to run to completion? Like, then yes, let's use Temporal for this.
It's a great rule of thumb. So what about the other way around? So what are the things you wouldn't use Temporal for?
Yeah, on my side, I would guard against using Temporal as a message queue. So Temporal has a very nice concept of signals. So you can actually send signals to a workflow instance, and that can be abused, and you can very easily build an entire message queue inside a single workflow. And Temporal doesn't scale well with that single concept. Usually you have to Temporal scales well with the number of running workflows in parallel. So if you have millions of workflows, it's not a problem. But if you have one workflow receiving a tons of signals, you will hit the issues that Alan was mentioning with continuous new and workflow history limit sizes. And Temporal is not really designed for high throughput message queuing system, like high throughput message queues like Kafka, for instance, would be. So yeah, another thing I can think about is CRUD applications. If you need to implement a simple CRUD API, you don't need to shove everything through Temporal. It just had overhead everywhere. So just use it sporadically in your application where things are needed.
Cool. Do you have any other ideas, or Alan, or that's more or less what you thought?
No, I have a couple more. I think one of them kind of refers to, I think Yeah, one of them refers to something Loic mentioned a lot earlier. So the first one is, I think that nothing that's super low latency, right? Like by definition, like if you have like queues and you are like, like having a durable store, like you're putting in a lot of latency in order to get the reliability trade-off, right? And so like temporal is not going to be ideal if you want like very, very low latency and you want that like very tight levels of control. And then the second thing I think is that if you're trying to shovel like large amounts of data through your system, right? Even, if you have the data converted, like this is not the ideal platform to be doing that, right? Yes, temporal has a lot of like, what's it called? Guardrails to prevent one workflow from killing another, for example. But still, you have like workers that are going to be like handling like maybe like thousands, millions of workflows in parallel. And so if you're shoveling large amounts of data, you always have the chance that one of them is going to suffer from the noisy neighbor problem and like take out your entire worker, right? So you have to like really keep that in mind.
And incidents do happen. So that's part of the process. Cool. Thank you both. We are going to go to Q&A now. But if you think solving those problems either on the platform side or on the product side are interesting to you, we have a lot of openings in our careers page, so do check out. We also contribute back to Temporal in several ways. SQLite backend, as Loic mentioned, as an example, but other things as well. So if you want to check out some of the things that we built and we upstream to Temporal, go to our open source hub, which is opensource.datoghq.com, and you can see some of the projects that we contribute to at Datadog. So we have one single question from the audience. So please add your questions if you have any others. But the question that we have is it possible in Temporal to set time expectations on workflow executions, given how part of histories can be rerun or scheduled in different systems?
I'm not sure about the second part of the question. I actually don't understand the second part of the question. However, like for Datadog workflows, right, we have a maximum lifetime of the workflow. And what happens is that we structure our temporal workflow to essentially get a signal, when the timer expires, and then terminate the Datadog workflow, do any cleanup tests, and so on. So yeah, absolutely, you can set a timer for what's it called within a temporal workflow, and you can terminate the workflow, or yeah, the flexibility is there. If the questioner could maybe clarify the second part, I'm sure Loic or I would be able to answer that.
Yeah, definitely. Temporal manages what they call durable timers on the backend side. So you can always have timeouts and manage them in the workflow code. You also have direct control over each workflow and activity, timeout and retry policies and all of that. So it's very flexible in that regard.
Good. So I have a question for Loic while we wait if there are any other questions from the audience. So you mentioned that Datadog contributed to SQLite. I know that that's part of a way to have a quickly development environment, probably not for production, but talking about Atlas and how we manage Temporal at Datadog. Are those different backends that you mentioned, like Postgres, Cassandra, etc.? Can our product team choose what backend they have, or is we run always on the same backend?
So as of today, we offer two flavors of Atlas. One backed by Cassandra, probably because it's the most battle tested on the upstream, basically. Because I believe that's what they used, or at least have used for a long time for Temporal Cloud. And we also provide an Atlas Lite instance, which run on top of SQLite for our disaster recovery scenarios, for our running workflows from laptops, for instance, or in development. That's only our 2 offerings. But we are looking at expanding our usage to Postgres and potentially provide that as to our customers.
When you say customer, you're talking about your internal customers.
Yes, the engineers at Datadog.
Yes. One of the things that I really like about internal platforms at Datadog is that you run them as really like a product. You talk about customers for your internal customers. You have SLIs, SLOs for your internal customers, which I think it works great, and it talks a lot about maturity of the engineering org.
Yes, indeed. And what I really like with platform is that they compound together. So we build platforms on top of platforms, and so we provide higher level abstractions to the rest of the engineers at Datadog, so they don't have to deal with low level details. It's really our mission, I think, in our team.
Fantastic. So we don't have any more questions, so I think we can wrap it up here. Alan, Loïc, thanks a lot for joining. Thanks everyone who attended for joining live. As mentioned, this is being recorded, so in a few days it will be available on our website. And again, see you next one. Thank you.